about derivatives. Right? So the first thing we're going to do is we're going to start with what is, if I give you arc sine of x, let's review that derivative. Right? Because the way you truly get good at taking an integral is you've got to be really good at taking a derivative. When I say really good at getting a derivative, it means if I put something down, you can just go ahead and give me the simplified answer. Now for this, it's easy. Like if I take the derivative of arc sine x, that's an easy one. That's going to be 1 over the square root of 1 minus x squared. Okay. Right. Is everybody okay with that? That's not the tricky part. Okay, next up. Here, let me change colors. What about arc sine of 2x? Derivative of arc sine of 2x.
2 over the square root of 1 minus
Okay. So I get 2 over the square root of 1 minus 2x squared, which is 2 over the square root of 1 minus 4x squared. Everybody okay with that? That pretty easy? There's our review, right? And here's the part that's not so nice. What about arc sine of x over 3? You think, how is that not nice, right? Do the same thing. Derivative of this is going to be, technically that 2 could have been off to the side. We just put it on top. Like you take the derivative of whatever this is and stick it off to the side. Well, if I take the derivative of whatever this is, I'm going to get the square root of, let's see, 1 over 1 minus x over 3 squared times 3. Everybody, and I need to start the, okay, times, whoops, 1/3. Is everybody okay with that? Same idea, right? Now, we did this, it's been a few months, but we did this. I want you to think of this as, because we got to clean this up. We can't have this. So I want you to think of this as 1 over, that 3 I'm going to put in front, so that's 3 times the square root of 1 minus x squared over 9. Are we okay from here to here? And now the tricky part. Do you remember we took a number outside and we put it inside the square root? It's been a while. And you're not used to doing it because you've never done it before, but until we did it last semester. But do you remember when we took the 3 and we put it inside the square root? When we put that 3 inside the square root, what did it become?
A 9.
It became a 9. Right? So when I take that 3 and I put it inside the square root, it's a 9. And when I distribute, do you see that I get 1 over the square root of 9 minus x squared? Right? Do you see that?
Yeah.
So, let's recap what we know. If you've got a 2 next to the x, right? Notice that 2 goes on top, you square the 2 in the bottom, right? If you got a 3 on the bottom, does it impact what goes on top? No, right? That 3 impacts our answer, meaning we get a 9 here. Okay, does everybody see what happens? All right, so here's our summary step. If I give you arc sine of 2x over 3, and I say take the derivative, what do we get? Combine these two parts. This is huge. This is what I need you to be able to do, right? I need you to be able to say, all right, if I see arc sine of 2x over 3, what's my answer going to be? Right? And we agree we're going to have a fraction. Can we agree there's going to be a square root in the bottom?
Mhm.
Can we agree there's going to be a minus sign here?
Yeah.
And the x is going to be on the right. Notice that's the same thing for all of these. And what I need to make sure is that we know what goes here, here, and here. What's going to go here?
So it's
4x squared. Right? If you've got a 2, right, you square that, we get the 4x squared, right? Did that 3 give me anything on next to the x? Since that 3 doesn't give me anything, the only thing that gives me something next to the x is something that's on top. And so that's going to give me a 4x squared. Right? Okay, what goes here? A 9. See, that 3 on the bottom gave me a 9 right here, didn't it? Notice that 3 on the bottom didn't do anything else, right? After the simplification, that 3 on the bottom gives me a 9 right here. What goes on top?
2.
Are we okay? The 2 goes on top? Notice the 2 here put a 2 on top. Did the 3 on the bottom give me anything on top? And so my answer is just 2 here. Does that make sense? Now, my suggestion for everybody, all right, for those of you that want to know how to do this, I need you to write this down. Is there a chart in your book that has this? Yes, right? I think what they'll have is, let's say I have arc sine of ax over b is equal to a over the square root of b squared minus a squared x squared. To me, this makes more sense than this. I don't know how y'all feel. Right? I like seeing stuff with numbers, but if you like seeing stuff with letters, this is the official thing that your textbook, or any textbook. If you look, like if you type in, what's the derivative of arc sine, they're going to give you this pattern. Okay? But what I'm going to do, I'm going to put this down, and I'm sorry for you at home, I need all of the board. Right? So write this down somewhere, because I'm actually going to write it over here. So I'm going to say arc sine of 2x over 3. The derivative of that is equal to 2 over the square root of 9, 4x squared. If you want to use the a's and b's, that's fine. I know I function better with numbers. Right? Is everybody okay? All right, next up. We have 3 inverse trig functions I need to talk about. So the next one's going to be, let's do arc, we'll do arc tangent x. And to refresh your memory, the derivative of arc tangent x is going to be 1 over 1 plus x squared, or x squared plus 1, it doesn't matter. Right? And we're going to do the exact same thing. I'm going to put a 2 on top, figure out what happens with the 2. I'm going to put a 3 on the bottom. We're going to figure out what happens with the 3, and then I'm going to do a 2 over 3 and find out what happens when we put them together. Everybody got it?
Yep.
Right? So, first we're going to start with, what about arc tangent of 2x? Well, if I take the derivative of arc tangent of 2x, that's going to give me, let's see, on the bottom I'll get 1 plus 2x squared. And then on the top, I guess I get a times 2.
Yeah.
So my final answer for this is going to give me 2 over 1 plus 4x squared. And when I look at this, it's kind of the same thing that happened with arc sine, isn't it? We've got our little pattern, right? We're going to square it on the bottom, right? Take the derivative of it and stick it on top. Everybody okay with that? Very similar, right? Very, very similar. All right. What about arc tan of x over 3? Same idea, right? I'm going to put this as, I'm going to put a 1 on top. That's going to give us 1 plus x over 3 squared times 1/3, right? Same idea. Let's clean this up a bit. All right? So if I clean this up a bit, that's going to give me 1 over, let's see, that's 1 plus x squared over 9 times 3. Okay? If I distribute the 3, that gives me 1 over 3 plus x squared over 3. But I don't like fractions. I don't like this layered fractions. Right? And since I don't like layered fractions, to get rid of them, I'm going to multiply top and bottom by 3. See how it's going to get rid of it? And so now I end up with 3 over 9 plus x squared. Right? So now let's talk about what happens with the 3 on the bottom. The 3 on the bottom gives us a 9 right next to where that 1 was. Very similar to what happened with arc sine, isn't it? You get the x squared. The difference is it also gives us a 3 on top. Remember in arc sine it didn't give us a 3 on top?
Oh.
Right?
That didn't do anything.
With arc sine, the bottom number, right? Think about it. With arc sine, the bottom number only changed that 1 to a 9. Didn't change anything else. With arc tangent, it changes the 1 to the 9 and it puts a 3 on top. So, if I give you, and I do apologize, I should have written higher. I wish I had one of those science boards that I could slide up. If I have if I have arc tangent of 2x over 3, actually, here, I'll write it over here. Let's talk about what this does.
It's a 6 on top.
Okay. We're going to get the 9 plus 4x squared on the bottom, right? Just like arc sine. Right? But what do we get on top?
6.
A 6. Because we get a 2 and a 3. I'm going to go ahead and say that's 2 times 3. Can I do that? We know it's 6, but I want to emphasize the fact that it gets the 2 and the 3 on top.
Oh, yeah.
Does that make sense? All right, so now when I'm writing down my little chart, I'll have arc tangent of 2x over 3. The derivative of that's equal to 2 times 3 over 9 minus 4x squared. And again, if you were to look this up in your book or any other textbook, they would say arctan of ax over b is equal to a times b over b squared plus a squared x squared. Do you say that's the same thing? I just like numbers. I mean, I work better with numbers, particularly with computation. Are we okay with arctangent?
The only difference is the times b on the top. Right?
Oh, whoa, that's a plus. Yes.
Oh,
Yeah. Because we're arctan, you're adding.
Mm-hmm.
Arc sine, you're subtracting. And the last one. Let's look up arcsecant x. The good news and bad news. The bad news is this is the one that's a pain. The good news is they rarely ask about it. And so this is 1 over x, the square root of x squared minus 1. Right? Technically there's absolute value bars here. I don't worry about those. The AP exam doesn't worry about them. Differences are, notice with arc sine, it's 1 minus x squared. With arcsecant, it's x squared minus 1. That part switched. So let's look up arcsecant of 2x and see what happens with the 2. Okay. Well, now when I plug this in, I end up with 1 over, well, that x is the stuff, so I get a 2x here. Square root of 2x squared minus 1 times 2.
The 2 comes from the derivative of stuff.
The 2 comes from the derivative of stuff.
Okay.
Does that make sense?
Mm-hmm.
And so now we end up with 1 over x, the square root of 4x squared minus 1. So what does the 2 do when it's right next to the x?
It just puts a 4x squared.
Just puts a 4 here, right? You square it next to the x. Doesn't give you anything on the top, right? Doesn't give you anything else. It just gives us the 4. All right, let's talk about, shoot. Oh, I need more room, okay. So I want arc secant of x over 3, right? This gets a little uglier. Actually, it gets a lot uglier.
1/3.
All right, so I'm going to get 1 over, so the derivative, so I'll get an x over 3 here, right? Because whatever this is has to go here. I get the square root of this thing squared, which gives me x squared. Can I just go ahead and say that's x squared over 9 minus 1? And then I'm going to say times 1/3.
Oh,
Are we okay? Because the derivative of x over 3 is 1/3, so that 1/3 goes over here. So, well, what the heck does this mean? Well, think of, here's your division bar, here's your division bar. What happens when I multiply this 3 times that x over 3? What do we get?
just that.
You see how that 3 is going to cancel that 3? And so that's going to give me 1 over x, and I get the square root of x squared over 9 minus 1. We don't like this whole fraction stuff, the layered fractions. And so the trick is I got to get rid of that 9.
You have to multiply by 9 over 9.
Multiply by 3 over 3. See, a 3 on the outside becomes a 9 on the inside.
And then put it,
Okay. And so this is I'm going to multiply by 3 over 3, right? So I get a 3 on top. Can I skip the step and say that that 3 is going to make a 9, and when I distribute, this is going to give me x, the square root of x squared minus 9? Is everybody okay with that? So, if there's a 3 on the bottom, what does it do? What does the 3 on the bottom create?
A 3 on top.
A 3 on top,
And a negative 9.
and it changes the 1 to a 9. Right? So if I'm going to do my summary, if I want to do arc secant of 2x over 3, and I take the derivative, what do I get? What's going to go on top?
3.
The 3 is going to go on top. Does anything change the x? Did anything change the x in here?
No.
Anything change the x here?
No.
No. So I just get an x. And what do I get on the bottom?
4x squared
4x squared
minus 9.
minus 9. Does that make sense? All right. So when I take the derivative of arc secant of 2x over 3, and I take the derivative, I get a 3 over the square root of 4x squared minus 9. Notice how they're similar. As far as the similarities go, here, I'm going to see if I can slide this all the way over. You may not be able to see, and I'm very sorry, it's like all sorts of distorted. But when you look at these, notice we get the 9 and the 4x squared on all of these on the bottom, right? Okay, so that's the same. The major difference is the numerator. Arc sine gives us whatever's next to the x on top. Arc secant gives us whatever's on the bottom on the top. Arc tangent gives us both of them. Does that make sense?
And there's not one that gives you both of them at the bottom.
No. Well, they all give you both at the bottom.
No, I mean like where you have to multiply them together.
No.
Okay.
Okay, are we all right? Yes.
The letter form of that?
Oh, so the letter form of this is if I give you arc secant of ax over b, when I take the derivative of that, I'm going to get b over x square root of a squared x squared minus b squared. That's the official one. Just curious, show of hands. Do y'all like the letter version or the number version? Show of hands, I say. How many people like the letter version? How many people like the number version? All right, so like nobody over, handful of people like the number version. That's just how I do apologize. I always teach to myself. I teach to my teenage self. Whenever I present material, I always try to think, what would my teenage self need to understand the material? Not what a book gives. Of course, my teenage self is just as weird as my adult self, so. All right. So, what the heck does that mean? Well, let's say I ask for the integral of 1 over the square root of 1 minus 16x squared. What does this look like?
1 minus 16. Oh, wait.
Which inverse trig function? Arc sine. How do you tell? Right? If it's 1 minus x squared, it's arc sine. 1 plus x squared, it's arc tangent. X squared minus 1, it's arc secant. All right? Does everybody see this as arc sine? And our job is we need to guess. And so you have to identify, oh, this is arc sine. So if I guess, I'm going to guess arc sine. And what is my guess?
4.
Are we okay? That's my guess? See how that's going to give me the bottom? And this is why knowing how to take the derivative easily is huge. Right? So what's the derivative of this?
4 over. Oh yeah.
Everybody okay? That's the derivative? How close is this to this?
Pretty close.
What do you got to do?
Divide by 4.
Divide by 4. So my answer is going to be arc sine of 4x all over 4 plus c. Did that make sense? Do you see how this works?
Yeah.
And the way that I teach this hinges on the fact that you can easily take the derivative. Right? Because if you can easily take the derivative, this doesn't take long, does it? Like you have to identify, okay, what inverse trig function am I using? Take the derivative and now fix it. All right? Let's try another one. What if I give you the integral of 5 over, let's do 36x squared plus 16. What does it look like?
Arc tan is 6x.
Are we okay with arctangent? How do we know arctangent?
Because it's like.
Do you see an x squared plus a number? Right? If you see x squared plus a number, you think arctangent. Okay? And now, can everybody sort of accept the fact that the 5 is decoration? If you see a number on top, I want you to think of that as decoration. So to think of this as decoration, just like pull the 5 off to the side and completely ignore it for now. Now here's the hard part. So you told me it was arctangent. What's your guess?
6x.
Okay, I'm okay with the 6x
Over 4.
over 4.
Oh.
Everybody see where we got the 6x? Everybody see where we got the 4? What's the square root of that?
6.
What's the square root of that?
4.
Whatever's next to the x is always going to give you the number that goes on top. Whatever the constant is going to give you the number on the bottom.
I thought it was.
Do y'all see it?
Yeah.
Can you see that with the pattern now? See why I like numbers? I think that's harder to see with the a squared and the a. I think it's easier to see with numbers. All right. And so now, let's take the derivative. What do we get? What goes on the bottom?
36x squared plus 16.
36x squared plus 16. What goes on top?
4.
24.
24. Remember, arctangent, whatever these
Oh.
numbers are, we got to multiply them.
Times 5.
Well, yeah, we'll put that at the very end. I don't care. It's decoration.
Okay.
What do I got to do? Is this?
Divide by
Divide by
I have to divide by 24. And so my answer is going to be arctangent of 6x over 4. I probably should reduce that. Divided by 24. Oh, the decoration is still there. Does that make sense? Right? Okay. Everybody ready? We okay with this? Oh.
What's the number on the
What?
Or what's on
Oh, dx. Handwriting's really bad. Fair question.
dx.
What does this remind you of? What does it match?
Arcsecant.
Arcsecant. So we're going to guess arcsecant of what?
W over 2.
Everybody see that?
Yeah.
Whatever's next to the x goes on top, right? Whatever the number is goes on the bottom, the square root of it. So whatever's next to the x is a 3x over 2. Now let's take the derivative and see how close we get. When I take the derivative of that, I get x square root. You see how we've created it so it's going to give me 9x squared minus 4. What's going to go on top? A 2. And when I compare these two, what are we off by? You're going to divide by 2. And so this gives me do you see how important it is to be able to take the derivative? Which is, in a normal circumstance, I would leave these on the board for a week while you're practicing. I erase them on test day, but I leave them so you have easy reference. Are we okay? Oh, let's do the tricky questions now. These are the straightforward ones, because they look exactly like you're expecting. So what if I give you this? What about the integral of dx over the square root of e to the 2x minus 1? Just kind of mix a whole lot of stuff in there. Ready? Anytime you see e to the 2x, you need to realize that e to the 2x is the exact same thing as e to the x squared. Just in general. Right? Everybody okay with that? Because anytime you have an exponent raised to an exponent, those get multiplied. Right? And so now this is really just the integral of dx over the square root of e to the x squared minus 1. What pattern does this remind you of?
Arcsecant.
Arcsecant. You're thinking, wait a minute, I should have an x off to the side, right? I don't know. Let's guess and see what happens. All right? What's your guess going to be? Arcsecant of what? What's your guess have to be? E to the x. Everybody see that's what our guess has to be? Because if it's arcsecant of whatever's being squared. Right now what's being squared is e to the x, so our guess is arcsecant x. All right, let's take the derivative and see how close we get. What's the derivative of arcsecant? Stuff, well, okay, I get to copy the stuff here. It's the square root of e to the x squared minus 1. What's the derivative of stuff?
E to the x.
Everybody see that's the derivative of this? What happens?
Oh, they cancel. Oh, and it's identical. So that your guess was right.
So you don't have to fix your guess. Said it was a tricky one, right? I warned you. Right. Is everybody okay?
Yeah.
All right. Okay, next up. Next tricky one. And this is actually really tricky. Really, 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 really tricky.
Sarah, they don't leave ever. And then they go through the week. It's the week week.
Everybody got it written down? Very, very, very tricky. And you're going to groan. And then after this, I'm going to put 3 problems on the board that are going to emphasize just how tricky taking an integral is. You haven't seen how tricky it is. You're going to kind of see here. All right, so what do? I don't know, but I'm going to break this up. I'm going to say this is the integral of x over the square root of 4 minus x squared plus 2 over the square root of 4 minus x squared. Everybody see how I can do that? Anytime you've got adding or subtracting on top, I can do that. All right. Now, how do you take the integral of this? Hint, I gave you something exactly like this 2 weeks ago. Is the derivative of the inside sitting outside? If I were to rewrite this and say this is the integral of x times 4 minus. Could you take the integral of that?
Yeah.
What's your guess?
To the 1/2.
Okay, it's going to give us 4 minus x squared to the 1/2, right? I'm going to take the derivative, so it's a 4 minus x squared to the 1/2. Take the derivative of 1/2, copy stuff. What am I off by? I think I'm just off by a negative. There's a minus 2. And so my claim is if you take the derivative of this, you get that. All right? What does this look like? Arc sine. And so if this is arc sine,
Of 2.
2 is just decoration, so I'm going to pull the 2 off.
Arc sine of 2x.
No. If there's a 4, it is arc sine. Where's the 2 going to? I realize, yes, there's a 4 there, so there's going to be a 2. Where does the 2 go?
Oh, 2 arc sine x. Over
What
2.
goes next to the x is next to this.
So over 2.
Over 2.
Oh. We have 9.
And that doesn't give me anything, so I don't have to fix it. So my decoration is still here. Do you see what I mean by this being tricky? This is why we have to practice a lot.
This isn't on tomorrow's quiz.
No, 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 no. What's on tomorrow's quiz is strictly, I'm going to throw a basic integral in there, but you're going to either use natural log or e.
And you said it was like 4 questions.
5. Okay. Maybe 6. Well, the problem is if so few questions, each one's worth a lot, right?
Yeah.
All right. But y'all see how that works? And so now I've got 6 minutes, and I want to show you 3 tricky questions. All right? Here are your 3 tricky questions. All right, ready? How similar do those questions look?
Almost identical.
Can everybody agree these look very similar? All right. Let's talk about them. What's your guess here?
Arctangent.
Is the derivative of the bottom sitting on top?
Yeah.
I'm going to ask that again. Is the derivative of the bottom sitting on top?
No.
Yeah, it is. Derivative of this is 2x. There's a x, right?
Oh, okay.
Can everybody see the derivative of the bottom sitting on top? What's your guess every time the derivative of the bottom is sitting on top? So your guess for this one is going to be natural log of x squared plus 1.
Oh. And then over 2, right?
Yeah, it'll be over 2 because this will give us a 2x. Right? So we have to divide that by 2. Does everybody see that?
Mhm.
What's your guess here? Perfect. X squared plus 1 to the negative 1. Because if I take the derivative, I get negative 1 times x squared plus 1 to the negative 2 times 2x. What are we off by?
Of 2.
A negative 2. Does everybody see that? And this may be mean. Yeah, we'd have to clean it up, but that's the answer. Is the derivative of the bottom sitting on top?
No.
Actually, no, I needed an x, not an x squared, right? Can everybody see the derivative of the bottom is not sitting on top?
Yeah.
Turns out, here, what I'd like everybody to do is take the derivative of arctangent of x squared and see how close you get.
Oh, I had two.
So, integrals are mean. Do y'all see that? The answer to this is you got to divide by 2. Right? Integrals are mean. These look almost identical, don't they? There's not much between these, is it? Notice you got 3 different answers. One is arctan, one's natural log, and one's just your regular power rule, right? How do you know the difference? Practice. That is the only way you know the difference. So, to be fair, tomorrow, the only integrals I'm going to give you will involve either e or natural log. I won't even put a regular one because I've just thrown a ton of stuff at you. And so the only thing that's going to be on your quiz tomorrow will involve e or natural log. Nothing other not other bases.
So like number 1.
Number 1's fair tomorrow, right? Because the derivative of x squared is 2x. Think of that x to the 4. Like when you take the derivative of this, you're going to get x squared plus 1, and the derivative of x squared is a 2x.